We'll be starting with new chapter today. All right, and the name of that chapter is rotational mechanics, rotational dynamics, rigid body dynamics. They have different names, but it's basically the same thing. Okay, so unarguably this is the most dreaded chapter in physics, right? सबको यही बोलता है it's so difficult, rotation तो होने वाला नहीं है, मत पढ़ो, it's very difficult. But the truth is they are right. Okay. It is slightly difficult. It is difficult. And why it is difficult? Because it is a blockbuster movie. All right, it's a masala movie. It has everything. It has action, suspense, drama, romance, everything. Okay, why I'm saying that? Because it has all the components of whatever we have studied till now. Okay, we have studied vectors. It will be used in rotation. Okay, we have studied kinematics. Obviously, it will be used in rotation. Laws of motion, free body diagrams. Okay, dynamic equation that we used in rotation. Then friction, obviously there will be friction. Circular motion will be there. Work, power, energy, energy conservation, all that would be there. Center of mass will also be there, and collision will also be there. So everything we have studied till now, why did we study that? So that we are able to study rotation. Okay, not really. Okay, but everything we have studied till now will be utilized, will be used in rotation. Okay, so the people who have a lack of concept in these topics, naturally they will face problems understanding rotation. Okay, but if you're clear with the basic concepts, it is not going to be difficult. Okay, it's going to be a little different because in rotation you'll have questions with multiple concepts. Okay, rotation mein, as I said, there will be a lot of concepts intertwined with each other. Okay, but the thing is, if you are clear with the basics, it should not be a problem. Okay, so it should not be a dreaded chapter, and we'll see that. And we'll go आराम से, will go easy. There is no rush to complete this chapter in 2 lectures, 3 lectures. और तुम्हारे स्कूल में जैसे 45 minutes में होता है. I don't know how. First 45 minutes I'll take to explain what is rotation. Okay, anyway, but we'll go slow. We have the entire month, probably 1.5 months, we are going to study rotation. So there is no rush. We'll take it easy. Okay, and it will be a wonderful end to mechanics. Okay, this will be a conclusion. So all that we have been studying. Okay, and the reason for this test, another reason for conducting this test was so that I get you revised. Okay, you revise everything before studying this topic. Okay, so whatever we have done, it will be a wonderful summary. Okay, so let's get started. Emotional speech. Okay. ताली बजा दो if it is so emotional. Okay. Anyway, so rotational mechanics, rotational dynamics. The first thing we are going to deal with is something called rigid body dynamics. Okay. So till now we have been dealing with particle dynamics. Okay. What does particle dynamics mean? What does particle dynamics mean? Size of the object is considered small, or the thing is the whole object behaves in a similar manner. Okay, if this is a pen, it is moving like this. The whole objects behave in a certain manner, in a similar manner. Okay, so in particle dynamics, it does not matter I'm applying force over this part of the body or this part of the body, because I'm assuming that this body is small and this will have similar kind of motion. Every point on this particle is going to have a similar kind of motion. Okay, that is meant by particle dynamics. But now we are moving to rigid body dynamics. Rigid body dynamics means that now it will be very important to understand if the force is being applied at its tip, or the force is being applied at its tail, or the force is being applied at the center. Okay, now that will become very, very important. Okay, secondly, what does rigid body mean? Rigid body means that the distance between the particles, it cannot change. Okay, so even if I'm pulling this, okay, if I'm pulling this, so there is W written on it, okay, and then this is R written on it. Okay, if I'm pulling it, do you see the distance between W and R changing? I'm compressing it. Do you see the difference between changing? I rotate it. Do you see the difference between the length of the distance between W and R? Is that happening? It is not. Okay, so the distance between the particles, the relative distance between the particles does not change in a rigid body. Is that clear? Okay, that is meant by rigid body dynamics. Is that clear? Okay, now let's understand what is rotation. Okay, before that, let's understand what is translation. Okay, now because we are dealing with a rigid body and we are dealing with an elongated body, it's not a point object. Okay, then we have to analyze all the points on this object. Okay, so what I've done is I'm going to choose 2 points on this body. Okay, and what I'm going to do is I'm going to move it like this. Okay, this pen, you see it here? It's just like that. I'm moving it like this. Okay, so you come here. So this point has a trajectory like this, and this point has a trajectory like this. Correct? What kind of motion is this? It's translational motion. Yes, it is translational motion. Any problem? Okay, we know that very well. Okay, now what I'm doing is I take this pen, I'll move it like this. Right, I move it like this. Okay, so I take it through random trajectory. I take it this pen through this kind of trajectory. Okay, what kind of motion is this? What kind of motion is this? Wave motion किधर से आया बे? Random motion. तेरा बात जैसा. Shubhe, what kind of motion is this? It is still translational motion. Okay, what is the similarity between these two? Huh? Kya? No, it's not moving in a straight line. It's moved like this. No. What is the similarity? Hmm? Parallel. Parallel. They are going through parallel trajectories. So a point over here and a point over here is moving in a parallel trajectory. Right? The point here and the point here, is that moving in a parallel trajectory? Yes, this curve is parallel to this curve. Is that correct? So those 2 points are moving in a parallel trajectory. So this is translational motion. Okay, this is translational motion. So this is translational linear. This is translational curvy linear. Right? It is curvy linear. The path is curvy linear, but it is still translational. Is that clear? Okay, so that is translational motion. So what is rotational motion? When those 2 points, so suppose I take this pen and I move it like this. Right, I take this pen and I move it like this. So what is happening? Probably something like this. Right, now what kind of motion is this? There is hidden translation in that. Okay, but this would be rotational motion, or we'll differentiate between pure rotation and pure translation. Suppose I move it like this. Okay, this point is stationary, but this point is going in a curved path. Okay, so what is this? This is rotational motion. Is that clear? Okay, so the trajectories of points, different points on the body would not be parallel, and that is how we are going to define rotational motion. Is that clear? Okay, rotation plus translation. Yes, you are right. This is rotation plus translation, but that we'll deal with in the last part of this chapter. Okay. Okay, so how do we define rotational motion? We define rotational motion. So suppose this is a body. Okay, so how do we define rotational motion? Every point on this body has to go in a circular motion. Every point on the body has to go in a circular motion. Okay, for example, let's pin it here. Okay, this is a lamina, this is a leaf, pin it here. Okay, now what you're doing is you're moving it like this. All right, you're moving it like this. So what is happening to this point? What is happening to this point? What is happening to this point? All those points are going to go in a circle. Is that correct? Okay, and the centers of all those circles lies on a line. Do you see that? Which line? This line, the line passing through this point where it is, let's say, pinned. Is that correct? Okay, so this line is known as the axis of rotation. Is that correct? This line is known as the axis of rotation. Alright, so all the points are moving in a circle, and the centers of all those points lie on the line, and that line is known as the axis of rotation. Plus, one more thing, One more thing, if you observe, the plane of all these circles is perpendicular to the axis. Do you get that? The plane of all these circles is perpendicular to the axis. So this is how we define a rotational motion. Okay, so this is the axis. We also say something about pure rotation. There is something known as pure rotation. Okay, give me an example of pure rotation. Fan. What is it that tells you it is pure rotation? What characteristic? The axis is stationary. Excellent. Okay, so velocity of the axis should be 0. If the velocity of the axis is 0, we call it pure rotation. And if the axis is moving along with rotation, we say it is rotational with translation. Is that clear? Okay, so pure rotation is the axis of rotation has to be stationary. Its velocity has to be 0. Is that clear? I hope we are all familiar with something known as angular velocity, right? D theta by dt. Angular displacement divided by time, you know that. Okay, so if I have to find the angular velocity of a rigid body, okay, I have to do certain things. For example, let's say this is a rigid body. I have this point, I have this point. Let's call this point A, let's call this point B. Okay, so suppose this has a velocity something like this in this direction. It has a velocity va in this direction, and this has a velocity, let's say like this, vb in this direction. All right, the distance between these 2 points is L. Okay, how do I find the angular velocity of this body? How do I find the angular velocity of this body? Okay, so what I need to do is, first of all, I need to resolve the velocities. Okay, first of all, I need to join those 2 points. Okay, to find angular velocity, I need 2 points, the velocity of 2 points. Okay, so first thing I'm going to do is I'm going to join those 2 points. Okay, the distance between those 2 points is L. Now I have to resolve the velocities perpendicular to that line. Okay, so let's call this what? Let's call this alpha, and let's call this beta. So this would be what? This would be VA cos alpha, and this would be VA sin alpha. So this would be VB cos beta, and this would be VB sin beta. Is that correct? Okay. Now 2 things come from here. First of all, is constraint valid here? Yes, no. Is constraint valid here? Constraint, what was the constraint in the string? What was that constraint? Yes, the length of the string does not change. Correct. So can you tell me the distance between these 2 points, is that going to change? It's not going to change. So the constraint equation, and what will be the constraint equation here? VA cos alpha is equal to VB cos beta. Is that correct? So that will certainly hold true. Okay, next we have to find the angular velocity. What we need to do is, we need to sit at A or sit at B. Make A or B your point of reference. Okay, so what you're going to do is, you sit at A. Okay, if you sit at A, what I want you to find out is, I want you to find out VAB, or let's write it down, VBA. Okay, let's find out VBA, the velocity of B with respect to A. What will that be? The velocity of B with respect to A. What will that be? VB cos beta. Why? The relative velocity of B with respect to A. Or it does not only have one component. It does not have one component. It has the other component also. First of all, so VB minus VA, so that will be this velocity minus this velocity. So this component and this component aren't the same. Aren't they same? They cancel out. VB and VA ka component parallel to the line joining them is that same. Yes, so they cancel out. Okay, so what are we left with? We're left with VB sine beta, and then we are left with VA sine alpha. So what will be your answer? Excellent, excellent. Yes. Take care of the direction also. Correct? So they are moving in opposite directions, so these velocities are in opposite directions, so they will have to add them. Is that correct? Okay, so the relative velocity is how much? It's VB sine beta plus VA sine alpha. Is that correct? Okay, so how will you find the angular velocity? The angular velocity is defined as the velocity divided by the distance between them. Correct? So this will be this divided by L. Is that clear? Okay, so for any rigid body, if you have to find the angular velocity, what do you need? You need 2 points, the velocity of 2 points. Then what do? You join those 2 points and you note down the length between them. Okay, then what do? You resolve the velocities along the line and perpendicular to the line. Along the line, the relative velocity would be 0. Perpendicular to the line, you need to find out the relative velocity and divided by the distance between them. That will give you the angular velocity. Is that clear? Now, there is something known as rigid body theorem. Okay, so rigid body theorem states that the angular velocity about any point for a rigid body is same. The angular velocity about any point for a rigid body is the same. Alright? So you just calculated VBA, you just calculated angular velocity of B with respect to A. Now if you wish to calculate angular velocity of A with respect to B, should that give me any different result? It's not going to give me any different result. Is that correct? Okay, so rigid body theorem states that the angular velocity is about any point or any axis is the same for a rigid body, and this theorem is extremely important when we go ahead and solve problems. Is that clear? So what this does is it simplifies things a lot, because no matter which axis you choose, which point you choose, the omega of a rigid body is always going to be the same. Is that clear? Can I rub this off? Okay, have you written down what is rigid body theorem? Alright, next what we are going to deal with is something known as torque, and you know this. Probably you know this already. Okay, so what is torque? R cross F, right? So torque is R cross F. So torque is the analog of force in rotation. Okay, like you need force to accelerate something, in the same way you need torque to angularly accelerate something. If you want to turn something, you have to apply torque. Okay, so torque is defined as, and torque, mind you, is a vector quantity. Torque is equal to R cross F, and I'll show you what is R, what is S. Suppose I have a body over here and it is hinged at this point. Okay, it is going to rotate about this point. Okay, so this is the axis of rotation. Okay, suppose a force is acting, okay, on this point. Okay, so what we're going to do is we're going to draw a vector which joins the axis of rotation to the point of application of force. This is the point of application of force, and this point is very important to calculate torque. Now it matters where the force is being applied. It matters. Okay, so that is the point of application of force. Okay, so torque would be equal to what? Torque will be equal to R cross F. So this is your R vector, this is F vector. I hope you know how to find the cross product. Okay, now in this situation, can you tell me the direction of torque? Yeah, what is the direction of torque? Perpendicular, inwards or outwards? Inwards. You don't sound so sure. Inwards, outwards. The direction of torque. And you're using your left hand. Pata tha. And that is why it is so important to revise. Vectors, bhai. Vectors, cross product. I'm not talking about quantum physics. I'm talking about vectors. Right? R cross F. How do you find a cross product? Yes, tell me. Or should I make you revise it? Yeah, you take your right hand. Then what? Right. So first of all, you need to join the vectors tail to tail. पहुंच गए पहला क्लास में. So you have to join the vectors tail to tail. Then you have to find out you're going to from R to F. So you're going to go from R to F. Alright, R to F. And this is going to give you the direction of the cross product. ठीक है? Is that clear? I hope. अब मत भूलना please. Okay. So that is going to give you the direction of torque. Okay. So if the direction of torque, if you see, is going away from you, how is the body rotating? Huh? Clockwise. Rotate away कैसे कर सकता है दोस्त? हाँ. जो बोला. Okay. So it is, if the torque is, you just found out the torque is going into the plane. If the torque is going into the plane, how is the body rotating? Or how is the body trying to rotate? Clockwise. Excellent. So remember this. If the body is trying to rotate clockwise, okay, trying. Why I'm saying trying? Because I'm not talking about the angular velocity. So it may happen the angular velocity is anti-clockwise and the torque is clockwise. So whatever force is trying to make it move in a certain direction, that is torque. Alright. So it is trying to rotate it clockwise. So the direction of torque would be going inwards. You get that? Right. So if R is like this, F is like this, you will see that the torque is coming out. So the body is trying to rotate in the anti-clockwise direction. Is that correct? So you understand the sense of rotation and the direction of torque. Is that clear? Any problem? Okay. So the way to find out torque is, okay, sometimes it's not very easy to, or it's not the most convenient way to find R cross F to find torque. Okay, so what we do is, we follow a few steps. What is the first step? Extend the line of application of force. Okay, my drawing is horrible, so it does not look like it's extended. I'll try to improve upon that. Okay, so what you're going to do is, first step, extend the line of action of force, right? Next step, drop a perpendicular from the point of axis of rotation to the extended line of action of force. ठीक है? सुनने में बहुत बड़ा लग रहा है, but physically you can see what is happening. So okay, लिख लोगे तो अच्छा रहेगा, but with enough practice आज, I don't think no, I can't trust you. Okay, so you drop a perpendicular from this point onto this line. Extend the line of action of force. Extend the line of action of force. Okay, so let's say this is the angle theta. What is theta? Theta is the angle between R and F. Okay, so if this is R and this is theta, this length would be how much? This length would be how much? R sine theta. This length would be R sine theta. Okay, now this is known as the moment arm or the lever arm, whatever you want to call it. Alright? Okay, so can I write this? Can I write the magnitude of torque as RF sine theta? Can I do that? Yes. Can I write the magnitude as R sine theta into F? Yes. What is R sine theta? R sine theta is the moment arm. Okay, so I can write it as R perpendicular. I'm not writing as sine theta or cos theta for obvious reason, because theta बदल देंगे तो आंसर गलत आ जाएगा. Okay, so I'm going to write it as R perpendicular. So what is this? This is the moment arm. So now you understand what is R perpendicular. Okay, that is the perpendicular distance between the axis and the extended line of action of force. Is that clear? Okay, multiplied by the force. So that is one way to find out. Perpendicular? Because this is perpendicular. I'm dropping a perpendicular from this point onto that line. That is why I'm calling it R perpendicular. Is that clear? Okay. What I can also do, and sometimes this may become more handy. Okay, what I'm going to do is I'm going to write as R into F sine theta. Okay, now what is F sine theta? That is the component perpendicular to R. That is the component perpendicular to R. So this is F sine theta. So what I can do is I can resolve force perpendicular to R, and then I can multiply it with R. Is that correct? So I can write it as R into F perpendicular. In different situations, you will find that different methods are handy. But there is no difference. There is no difference. It's exactly the same as R cross F. It is same as R perpendicular into F or R into F perpendicular. Is that clear? Can I rub this off? Okay, so this is the axis. This is the axis. Okay, so we have a few cases. Case 1. So what is case 1? The force applied is parallel to the axis. Force applied is parallel to the axis. Okay, what do you think will be the torque? The torque would be 0. Yes, no. Why? You can still find R cross F, can't you? You can still find R cross F. It will not rotate. Okay, so understand this. The axis of rotation is like this. How can this object rotate? It can rotate like this in the plane of the board. For example, take that door. Okay, take that door, or let's say, do I have something? Okay. Suppose this is a door. Alright, suppose this is a door. Alright, so what is the axis of rotation? This is the axis of rotation, going like this. Okay, now I'm applying a force parallel to the axis. Do you expect it to rotate? It is not going to rotate. Is that clear? That is why the torque would be 0, because it does not have this degree of freedom to rotate. Is that clear? So wherever the force is parallel to the axis, the torque would be 0. Now the force intersects the axis. The force intersects the axis. What do you think the torque would be? 0. Why? Exactly. If you apply force on the hinge of the door, do you expect it to rotate? It's not going to rotate. Alright, so if the force is passing through the axis of rotation, the torque would be again 0. Okay, case number 3. F is perpendicular to axis and not intersecting. Not intersecting. Okay, so F is perpendicular to the axis, but it's not intersecting. Okay, so how would that look like? How would that look like? So this is the axis of rotation. Okay, so any line which lies in the plane of the board would be perpendicular to this axis. Yes or no? Okay, so that force could be anyway on this plane. Is that correct? And it is non-intersecting. So your force could be something like this. Or force could be like this. Force could be like this. You get it? Okay. Now this is the usual case, what we have seen already. Alright, this is the usual case. So in this case, how would you find the torque? Simple, R cross F. So in this case, you'll simply find tau is equal to R cross F. That is the most general case we're going to come across. Clear? Now case 4 would be force and axis are skewed. You understand the meaning of skew lines? You don't understand the meaning of skew lines. Okay, so skew lines mean they are non-parallel and non-intersecting. Two lines which are non-parallel and not intersecting. Is that possible? Not parallel and not intersecting. Is that possible? Think beyond 2 dimensions. In 2 dimensions, two non-parallel lines have to intersect, but in 3 dimensions, for example, you have this line and you have this line. Okay, then they're never going to intersect, and they're also not parallel. Okay, so how would that look like? How would that look like? That would look like something like this. Is that correct? Okay, so that would be in a different plane. Is that correct? Okay, now how do you find the torque? How do you find the torque? So first of all, what you're going to do is you are going to resolve this along the plane and perpendicular to the plane. Okay, the first step is you resolve it along the plane and you resolve it perpendicular to the plane. Okay, so the component of force perpendicular to the plane becomes parallel to the axis. Yes, no? So the torque because of that component would be 0. Then what does it become? It becomes case number 3. Now you can find out the torque using that. Is that clear to everyone? Okay, so if it is skew, what you're going to do is you're going to resolve it perpendicular to the plane and parallel to the plane. The component of force perpendicular to the plane will become parallel to the axis, so it will have no effect on torque. Is that correct? And the component of force which becomes perpendicular to the axis, you know how to deal with that. Is that clear? And that pretty much sums up everything. So now you can find torque for any kind of force and axis of rotation. Clear? Okay, write this down. Whatever I said. Okay, write it in your own words. Okay, so we have learnt that torque is a vector quantity. Okay, torque is a vector quantity. Okay, so generally what we are going to see is the rotation is taking place in a plane. Generally 3-dimensional में rotation probably तुमको नहीं दिखने को मिलेगा. Okay, that will become a little नहीं very complicated. Okay, पहले 2 dimension में सीख लेते हैं. Okay, so if something is rotating in a plane, it can either rotate clockwise or it can rotate anti-clockwise. Is that correct? Okay, so like you choose for force, like you choose the force in this direction is positive, then the force in this direction would be negative. Similarly, you have to choose. If you choose the clockwise torque to be positive, you'll have to choose the anti-clockwise torque to be negative. Okay, you have to take both those directions into account. Is that clear? Okay, now let's just practice a few problems that you understand how to calculate torque. और वो थोड़ी देर बाद कर लेते हैं, चलो कर ही लेते हैं. Let's do that. Okay, a little bit of practice on calculating torque. Didn't I tell you this film also has romance? Okay, so find the net torque. See if you can do this. Find the net torque. So keep in mind clockwise torque and anti-clockwise torque. O is the axis of rotation, yes. Or not necessarily the axis of rotation. See, you can calculate torque about any point. Okay, it does not necessarily have to be the axis of rotation. Okay, you can calculate torque about any point, any axis. Centimeter. Done? Let's see. Let's see. Let's start with this one. Let's start with this one. Okay, first of all, you need to understand the direction of torque. Okay, मतलब clockwise है या anti-clockwise है? So tell me about this force, or tell me about this torque. Is it clockwise torque, anti-clockwise torque? Clockwise torque. So what you need to think is, you hinge this point, you pin this point, and then you try to figure out that this force is trying to rotate it in which sense, right? So it is, if you hinge it here and you apply a force here, what will happen? It will turn like this. Okay, so that is clockwise. Okay, now what is, how do you find the torque? You extend the line of action of force, so, drop a perpendicular. Okay, do we need to do that? It is already perpendicular. Alright, so this 4 centimeter becomes what? It becomes the moment arm directly. Is that correct? Okay, so we are choosing the clockwise torque as positive, the anti-clockwise torque as negative. Okay, my choice. Okay, so this will become 10 multiplied by what? That will become 10 multiplied by 4. Okay, unit ka will take care later on, but this will become 10 multiplied by 4, so that will be positive. It's clockwise torque. Okay, now let's get to this one. What do? Extend the first of all, the torque is anti-clockwise. Yes. Now what do? Extend the line of action of force. Very good. And then drop a perpendicular. So this is 6, this is 37 degree. What will this distance be? 6 sine 37 degree. Okay, so the force is 15 and this is 6 sine 37 degree. My job is done, and it is anti-clockwise. So I am going to write minus 15 into 6 sine 37 degree. Is that clear? Any problem? कर लेंगे ना, एंड में कर लेंगे, याद रख अभी. Okay, next. What about this? What will be the torque? 0. It is passing through O. It is passing through the axis of rotation. Okay, so the torque would be 0. Okay. Now what about this? Anti-clockwise. Absolutely, the torque is anti-clockwise. How do you find out? You can do two things. Or what will be better in this case, na? What will be better is you resolve force. Okay. What will be better? You resolve force. Resolving force would be very simple in this case. Why? So this is, okay, so you will resolve the force perpendicular to R. Okay, this is R. So this is force. This is 150 degree. So this will be how much? This will be 30 degree. No, 30 nahi, 60 degree. कैसे? This entire thing is 150 degree and this thing is 90 degree. हाँ, तो ये 90 होगा ना, perpendicular है. Okay, so this angle would be how much? 60 degree. So you can easily resolve force. So this force ka component in this direction will become what? It will be 20 cos 60 degree. Is that correct? Okay. So you have resolved force and multiplied that by R. Okay, so you will get minus, because it is anti-clockwise, and this will be 20 cos 60 degree multiplied by what? Multiplied by what is the distance? 4 centimeter multiplied by the distance. Is that clear? So this turns out to be how much? 40 minus sine 37 degrees 3 by 5. तो मतलब 18 बचेगा, and then this is cos. Okay, I missed this. So that is 3 by, this is 3 by 5, so 18 into 3, that will be 54, yes. And then this would be how much? 10 fours are 40. So that will be minus 54, and I can write Newton centimeter. Or you can write minus 0.54 Newton meter. Is that clear? Any problem finding torque? Okay, so you can choose whatever method you like to calculate torque. Whatever you find convenient. Clear? Okay, next question. Write down the next question. A cubical block of mass m, a cubical block of mass m and edge A slides down a rough inclined plane of inclination theta, slides down a rough inclined plane with inclination theta with a uniform speed. With a uniform speed. Find the torque of the normal force. Find the torque of the normal force acting on the block about its center. Torque of normal force acting on the block about its center. Something like this would be happening. Okay, so what will be the torque of the normal force? Yes. Yeah, because the normal force would be passing through the center. Okay. Now we'll understand that it's not necessarily that normal force is always going to pass through the center. Okay, things would change here, but that we'll see a little later. But for this case, what is going to happen is normal force is passing through the center. Okay. Now in this case, if I ask you, find the torque due to the frictional force about the center, can you find that out? Mg sine theta into a by 2. Okay, so this is the force, this is the perpendicular, and how much is this? A by 2. Okay, so what will be the torque? The torque would be mg sine theta into a by 2. Is that clear? Or actually not, actually not. So this has an element of toppling. Okay, we'll deal with this later. This has an element of toppling. The torque of the normal force will not be 0. We'll discuss that later, don't worry. We'll discuss this today itself. Okay, so probably not the best example for you right now. Okay, anyway, but you understand how to calculate torque. Is that clear? Okay. Now what we also want to understand is, like, force is equal to ma, and which force? The external force. Okay, like the external force is equal to m into a, there is something known as moment of inertia. This quantity I is known as moment of inertia. Okay, so moment of inertia is the analog of mass in rotation. So how we use mass in translation, we are going to use moment of inertia in rotation. Okay, so basically, what is mass? What is mass? It's an intrinsic property. What happens because of that intrinsic property? Substance has mass. Matter. Everything that occupies space and has mass is called matter. And how is matter defined? So that is how matter is defined. How is mass defined? That quantity of matter. पहले किसको define करें? Okay, so इसका definition depends on matter. Matter का definition depends on mass. Right. Anyway, so mass is a measure of inertia. Alright, it is a measure of inertia. What do you mean by inertia? Yes, it resists change. Alright, you are sleeping, you don't like to be disturbed. Alright, if you are playing, yes, you want to get disturbed. Why inertia काम नहीं करता है? Okay, but if you are doing something, you want to keep on doing that. Okay, inertia will work in such a way that if you are playing, you want to keep on playing. Alright, if you are having fun, you want to keep on having fun. Okay, if you want to sleep, you want to keep on sleeping. Okay, until an external force. What is that external force? Parents. तेरे केस में तो पक्का. Until there is an external force, you will continue to do what you are doing. Alright, so that is inertia. So mass, what it does is, if something has a larger mass, it is more difficult to accelerate it, right? If something has a greater mass, you need a greater force to accelerate it, correct? Similarly, if something has a greater moment of inertia, and we'll see what that is, but if something has greater moment of inertia, it is more difficult to set it in rotation. Clear? Okay, we'll deal with moment of inertia later in detail, but right now just understand that the external torque is equal to I into alpha. Okay, like internal forces cannot accelerate a body, similarly internal torque cannot angularly accelerate a body. Is that clear? Any problem? Clear? So we will keep this equation in mind. Okay, I'm not deriving it. Okay, if you want, you'll not need this derivation first of all. If at all you want to see, you can consult any standard textbook. Okay, it'll be there. Okay, but we are not going to derive this in the class. Okay, what does equilibrium mean? Net force is 0. That's what we have been studying. Equilibrium means net force is equal to 0. all the forces are balanced. हाँ, अभी तक वहाँ तक सीखे. All the forces are balanced. If it is in equilibrium, what have we studied? That the net force on the object would be 0. Okay, but now we are going to talk about two kinds of equilibrium. So one is the translational equilibrium. Translational equilibrium. The next is the rotational equilibrium. They are independent of each other. They are independent of each other. Okay, is this fan in translational equilibrium? Yes, hopefully yes. तो किसी के सर पे तो गिरेगा. Alright, so this fan is in translational equilibrium, right? But is this fan in rotational equilibrium? No. Is that correct? Okay, so they are independent of each other. What does translational equilibrium mean is the summation of all the forces would be equal to 0. If the acceleration of the object is 0, then the summation of all the forces would be 0. Rotational equilibrium means the angular acceleration is 0. That means the net torque, the summation of all the torques would be equal to 0. Is that clear? Okay, so what they can do is they can give you different situations. So you'll have to use your knowledge of forces. And then what we need to do is, if something is in equilibrium, translational equilibrium, the net force is 0. If something is rotational equilibrium, the net torque is 0. So what we're going to do is, we're going to balance all the forces, we're going to balance all the torque, there will be some variables, there will be some constants, and then you write down equations, you solve it, you find the variables. That's the way it's going to be. Is that clear? Okay, so we can take a few examples. Okay, let's take a simple example. Very common question. तो इसीलिए तो पहले common कराएंगे फिर तो uncommon कराएंगे. First let's get familiar with this. Very common question. We'll see variations, don't worry. Is the length given? Not required. Okay, so this is the wall, this is the floor. There's a rod which is leaning against the wall. The wall is smooth. The floor is rough. Okay, this angle is 53 degree. The mass is given as 10 kg. Now the question is, find the normal and frictional forces exerted by the floor. Find the normal and frictional forces exerted by the floor. Okay, what is the first step? What? Free body diagram. आ गया. Back from blast from the past. Okay, first of all the free body diagram. Okay, in a uniform gravitational field, छोड़ो. अभी के लिए everything is uniform gravitational field. Okay, so the weight is going to act at the center of mass. The weight is going to act at the center of mass. Okay, now what will be the direction of normal force over here? This will be upward. Let's call that N2. What will be the direction of friction? The direction of friction would be right side, because this will have a tendency to slip out. Okay, so the direction of friction would be inside. The normal force over here would be like this. Okay, समझ आया? Okay, I hope you remember free body diagrams. Okay, so the first question is this body in translational equilibrium? Yes, no? Is this in translational equilibrium? Is it moving? It's not. So it is in translational equilibrium. Okay, so first of all we are going to write equations for translational equilibrium. Next we are going to write equation about rotational equilibrium, because this body is also in rotational equilibrium. Okay, so first let's find out summation of F is equal to 0. How do we do that? We resolve forces in two mutually perpendicular directions, और हर direction में net force को क्या कर देना है, zero कर देना है. Okay, so in this case it is already resolved. Okay, तो वो काम भी easy हो गया. Yes, very good. So the first equation would be, what is the force in the horizontal direction? N1 and F. So they need to balance each other for net force equal to 0. So N1 becomes equal to F. That will be equation number 1. Then the vertical forces N2 and Mg. So this will become N2 is equal to Mg. Okay, we also need a third equation because there are 3 variables. Okay, what do? We find out torque. Okay, so if the object is in, or if the body is in rotational equilibrium, the torque would be 0 about any point you choose, any axis you choose. That is the comfort you have. Okay, you can choose any axis. You can choose this, you can choose this, you can choose this, you can choose somewhere here. Does not matter. And you can try it. यहाँ पे एक axis choose करो and you find out the torque. It will still be 0. Alright, so what we think is, what would be more convenient for us? The center of mass, are you sure? Yes, you're absolutely correct. So you can find out the torque about the center, no problem. You can very well do it. Okay, but I'm going to choose an axis which passes through this point. Why? Because then the torque of friction and normal force becomes 0. Okay, so in that, what I'll have is only 2 torques I have to write. Correct? If I find out the torque about this point, how many torque I have to write? 3 torques I have to write. Correct? So that becomes a little convenient. But still you're going to get answer in any manner you want. Okay? Okay, there is no problem. You want to calculate the torque about the center? A lot of times we do. And you'll get the answer, no problem. Okay, so let's find out the torque about this point. Okay, how do we find that out? Extend the line of action of force. So if I'm calculating the torque for mg, okay, so what I'm going to do is I'm going to extend the line of action of force, then I'm going to drop a perpendicular. So I have to find what? I have to find this perpendicular length. How do I find the perpendicular length? This angle is 53 degree, so this angle will also be 53 degree. If the total length is L, then this length is L by 2. So this length becomes what? L by 2 sine 53 degree. Okay, and is this torque clockwise or is this torque anti-clockwise? सोच के बोल, सोच के बोल. Where is your axis? Where is your axis? Clockwise, anti-clockwise? Clockwise. This is the axis and this is the force, so we'll try to turn it clockwise. Okay, so the clockwise torque becomes mg multiplied by what? This distance, and that is what? L by 2 sine 53 degree. L by 2 sine 53 degree. So that is the net clockwise torque, and that would be balanced by the net anti-clockwise torque. Okay, now I have to find out the torque due to N1. What do? Extend the line of action of force, drop a perpendicular. Okay, so if this is 53 degree, this is also 53 degree. What is this length? L. So what will this length be? L cos 53 degree. Is that correct? Okay, so what will be the net anti-clockwise torque? That will be equal to N1 into L cos 53 degree. Is that clear? Okay, so L gets cancelled. That is why it is not given in the question. So this becomes N1 is equal to mg, and this becomes tan 53 degree divided by 2. So mg is how much? Mg is 100. Tan 53 degree is 4 by 3 and divided by 2. So this gives you 200 divided by 3 Newton. Clear? Okay, but what do we need to find out? We need to find out friction. So it's here. So the friction is equal to how much? The friction is equal to N1, that is 200 divided by 3 Newton. Correct? And then what do we need to find out? We need to find out N2. N2 is already here. N2 is already here. Clear? N1 is acting on which line? Matlab? N2 was acting on mg. What do you mean? No, 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 no. About which point are we calculating torque? We are calculating torque about this point. Okay, we are not calculating torque about this point. We are calculating torque about this point. So that the torque of N2 and F becomes 0. Okay, so the force passes through the axis, the torque is 0. That's what we are doing. Alright, so mg ka torque is about this point, clockwise. N1 ka torque is still about this point. Now don't do this. That for certain forces you find the axis up, you find the torque about a certain axis, and then certain other forces you find the torque about certain other axis. No, don't do that. Choose one axis, find all the torque about that particular axis only. Is that clear? Can I rub this off? You have seen this kind of stool or this kind of what do you call step. It's used by painters or some people who work. Okay, at the center there is a rod kind of thing. Take it. Otherwise this will not stay like this. This will come down. Okay, at the top there was a man, but I had difficulty drawing the man, so that is a weight of 80 kg over there. Okay, now this length is given to you 1 meter, 1 meter, the angle is given to you 60 degree. It's symmetrical. All right. Okay, so the question is, find the tension in this support. Find the tension in this support. That's the question. Think, give it a shot. Negligible. Okay, and also the floor is frictionless. Also the floor is frictionless. Draw the free body diagram first. Alright, did you draw the free body diagram? Okay, so free body diagram would be something like, let's remember this 60 degree. यहाँ पे ATG होगा. There will be tension over here, there will be tension over here. And there will be normal force from the ground. And I can say both the normal forces would be same. Why? The condition is symmetric. Okay, so this will, both of them would be N. Okay. So is it in vertical equilibrium or is it in translational equilibrium? Yes. What is the equation you can write? 2n is equal to ATG. Excellent. You can write 2n is equal to ATG. What are the vertical forces? 2n and ATG. So 2n is equal to ATG. Okay, so यहाँ से मिल गया n is equal to 40g. Excellent. Okay. Next, for horizontal equilibrium, T is equal to T. Okay, for horizontal equilibrium, T is equal to T. Okay, that becomes an identity. Okay, next, we need to find out tension. Okay, we need to find out tension. Okay, so what we have to do is we need to balance the torque. Okay, we need to write the torque equation. Okay, now tell me about which point should I write the torque equation? Center of this. Okay, ठीक है. Okay, excellent. Write down the equation. Okay, let's write it together. Check it. What is the torque of the tension? 0. Okay, torque of tension is 0. So tension does not come in my equation. How do I solve it? Okay, the torque of tension is T into 0 plus about this point N. Okay, so what do I need to calculate? I need to calculate this distance. Okay, so extend the line of action of force, drop a perpendicular. So I need to calculate N multiplied by this distance. How do I find that distance? How do I find that out? Okay, so this is 1 and this angle is how much? 30 degree. This is 1, this angle is 30 degree. Nahi, I need to find out which distance. This distance plus this distance. Okay, so that will so this distance would be sine किधर से आएगा? Tan आएगा ना? Tan 30 degree is this by this. So this would be 1 tan 30 degree. So this length will also be how much? This length will also be 1 tan 30 degree. Correct. So the moment arm becomes what? 2 tan 30 degree. Okay, so this will become N into 2 tan 30 degree. Okay, that is the net clockwise torque. This mg ka torque will be what? 0 because it passes through the center. Okay, now this will be equal to the anti-clockwise torque. What is the anti-clockwise torque? T into 0 symmetric conditions, so N into 2 tan 30 degree. Right. So what is the conclusion? We cannot find the tension. Nahi. Okay, so what we have to do is, okay, so this problem may arrive. Okay, so what we have to do is, if something is in equilibrium, a part of that something can also be in equilibrium. You have not dealt with this concept because always that something had been one thing. Okay, so there is no parts of the system. Okay, but now there are parts of the system. So if something is in equilibrium, all of its parts would also be in equilibrium. Is that correct? Okay, so what we're going to do now is, because we want tension in our equation. Okay, so what we're going to do is, we're only going to draw the free body diagram for one end of the ladder or one leg of the ladder. I'm only going to draw the free body diagram for that one. Is that correct? Okay, so what will happen? So T is here, this is tension, this is normal. Then there will be normal force from where? From the object kept there. Okay, and there will also be a normal force. There will also be a normal force from this end of the ladder or this leg of the ladder. They are in contact, so there will be another normal force. Now that normal force would be in any direction, I don't know. So the situation would be something like this. Is that clear? Okay, now what should I do here? About which point should I calculate torque now? Very good, very good. Because first of all, I don't know what will be the direction of n prime. I don't know. Alright, so it's better you choose this point so that the torque of n and n prime becomes 0. नहीं, n already है, इसको n prime double prime बोल देते हैं. Okay, so the torque is already 0, so I don't need to worry about what is the magnitude, what is the direction. I do not want to worry about that. Simply, I have how many forces? I have 2 forces. Balance the torque, get the answer. Now write the torque equation. Okay, so this is 1 and this is also 1, and this angle is how much? 30 degree. Now you can use that to find the torque. Okay, write down the torque equation. तो डायग्राम क्यों बना रहा है इतना? इक्वेशन पर इक्वेशन तो लिख. I don't know. Let's see what is the equation. Were you able to write the equation? L is equal to? ठीक है, let's see. Let's see. Okay. Is everyone able to write the torque equation? चलो नया बालक लोग से पूछते हैं. नया बालक, ओए बता, torque equation लिखा? क्यों? अभी तो सिखाया लिखना. How do you write the torque equation? Extend the line of action of force. Extend. This is tension. Extend the line of action of force. Drop a perpendicular. Drop the perpendicular. So how much is the moment arm? 1. So what will be the torque? Tension is T. Torque would be? 1 into sine 30 degree. Q. Force into the perpendicular distance. What is the force? The force is T. What is the perpendicular distance? 1. So torque would be T into 1. Okay, and this torque would be clockwise, anti-clockwise? Anti-clockwise. Alright. Then, normal force. Extend the line of action of force. Drop a perpendicular. Well, that is same as what distance? That is same as this distance. Is that correct? So this is 2. So this would be 2 tan 30 degree. This would be 2 tan 30 degree. So this will be equal, and this is clockwise torque. So this will be n into 2 tan 30 degree. Clear? Okay. So this comes out to be how much? T is equal to n. What is n? N is 40g into 2, and tan 30 degree is how much? 1 by root 3. So this comes out to be 800 divided by root 3 Newton. नहीं. Why tan 30 degree? Where is the force? Where is the force? Okay, if you have confusion, पूछ लो, अच्छे से पूछ लो. Let's begin with from scratch. This is the force, this is tension. What do we do? Extend the line of action of force, drop a perpendicular. So what is the moment arm? That is 1, right? Is that clear? Is that clear to everyone? Any problem? Because if you can't write the torque equation, आगे मजा नहीं आएगा. Alright, you should be very comfortable writing the torque equation. Like you're comfortably, you can comfortably write the force equation. You should be equally comfortable writing the torque equation. Is that correct? N clockwise होगा. Yes, absolutely. N will be clockwise. Is that clear? कोई confusion है? पूछ लो अभी. There's no problem. I can tell 10 times. I don't have a problem with that. Clear? Sure? Okay. Hmm. Hmm. Okay. Hmm. No, the thing is about which point you want to calculate the torque. Let's without torque, how would you solve? Huh? Okay, okay, okay. नहीं, but you're going to miss one force. Which force are you talking about? यहाँ का force. So you are telling me कि this leg का equilibrium we are talking about, right? We can write the equation of translational equilibrium of this leg, right? Then there would be a force from here, no? The force exerted by this leg on this leg, that you're going to miss. Is that clear? Now is this clear to everyone? Can I rub this off? पुली नहीं एक्सप्लेन कर रहे हैं मेरा ड्राइंग को इंटरप्रेट मत कर दिस इज एब्स्ट्रैक्ट आर्ट you won't be able to understand. Let me explain. Okay, so there's a meter scale. Okay, this is the meter scale. Meter scale has length. What? Arey, this is a meter scale. हाँ, you're right. This is a meter scale, and this is supported by 2 threads. झूल रहा है. इतना भी abstract नहीं है. All right. So this is a meter rule. What is the length of a meter rule? Okay, this is supported by strings of equal length from the ceiling. All right, the rule has a mass of 200 gram, and then at the 70 centimeter mark, there is an object of mass 20 gram kept there. ठीक है? Object of mass 20 gram kept over there. So the question is, find the tension in both the strings. Find the tension in both the strings. Is the question clear? Go for it. रेडियस नहीं रे Okay, there's a meter rule. On the 70 centimeter mark, there is something suspended which has a mass 20 gram. ठीक है? That's clear. Okay, so you have to find out the tension in both the strings. (200 gram). The scale has a mass 200 gram. Mm, so equilibrium, किसका equilibrium के बारे में you are thinking? Whole system. Meter scale. ठीक है, you are thinking about the equilibrium of meter scale. So you list down all the forces on the meter scale. Hmm. Okay. So you are telling me the tension in both the strings is same? Yes, no. तो वही तो किया तू, एक टेंशन निकाला है. You chose which point? Okay, you chose this end. दिखा 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 फिर से दिखा. Then let me check again. 30 centimeter. So you have chosen this end, na? That end. This is the point about which you are calculating torque. So, okay. So 20 gram into 30, 20 g into 30 centimeter. Okay, ठीक है. Plus. Okay, and then you forgot about one force. कौन सा? बोल. जो निकालना था. You have to find this, na? T1, T2. So you did not write the equation for this one. ओ मेरे को दिखा नहीं. ओके 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 ओके. कमाल करता है दोस्त. इधर लिखा है सेंटीमीटर में, इधर लिख रहा है मीटर में. द इक्वेशन इज करेक्ट. द इक्वेशन इज एब्सोल्युटली करेक्ट. द थिंग इज यूनिट्स थोड़ा मिसमैच हो गया. दैट इज व्हाई आई कुड नॉट फिगर आउट कि यू हैव रिटन 1 मीटर. ऑलराइट. यस, उसको ठीक कर ले, बाकी ठीक है. T2 24. I don't know the answer. We'll see. Uh-huh. और इक्विलिब्रियम, ट्रांसलेशनल इक्विलिब्रियम के बारे में भी सोच सकते हैं. वी कैन थिंक अबाउट वर्टिकल इक्विलिब्रियम. वहाँ से भी आ जाएगा. ओके. एक 10 का लोचा हो गया. सो 200 ग्राम इज 0.2 kg. तो 2 kg तो लिखा है. अच्छा नहीं, इनटू जी कर दिया है. ओह ठीक है ठीक है. देन दैट्स ऑल राइट. सो एंड द टॉर्क इज अबाउट विच पॉइंट? सेंटर. ओके. So 0.5 T1 plus 0.2 mg. Which mg? This mass. Okay, okay is equal to 0.5 T2. Yes, correct. I don't know the answer. Show me the equation. Yeah, correct. Well, I'm not checking your calculation. Your equation is correct. Okay. So free body diagram. First of all, free body diagram. T1, T2. Well, with the mass act, the mass will act. इसको capital mg ले लेते हैं. Okay, at the center, at the 50 centimeter mark. ठीक है. Now this is in equilibrium. Okay, that means what? इसका जो weight होगा 20, whatever is the weight, that will be balanced by the tension in the rope. So that same tension is going to act over here. Okay, तो अब इसको भूल सकते हैं. Now this is the situation. So this tension is equal to this weight, and this tension is acting here. मतलब the weight is acting here. We can assume that. Correct? Okay, now let's write the equation. So first of all, let's write the equation for vertical equilibrium. So everything is in vertical equilibrium, so that will be equal to T1 plus T2, the upward forces, equal to, this would be 0.2 into G, 0.2 into G, plus iska weight. How much is that weight? 0.02 into G. That will be 0.02 into G. Is that correct? That will be equation number 1. Second equation is you have to balance the torque. Okay, if you have to balance the torque, what you can do is you can calculate the torque about the center, no problem. Okay, but a smart thing would be calculate the torque about the ends. Why? Because that will eliminate a variable straight away. Okay, so we can calculate the torque about this point T2. You get this? You can do it. You can calculate the torque about the center, no problem at all. Okay, but the smart thing would be to calculate it about the end. Is that clear? Okay, so let's write the equation. First of all, let's write down the torque of T1. What will be the torque of T1? This is the force and this is the perpendicular distance. So that will be T1 into 1 meter or T1 into 100 centimeter, does not matter. So this becomes T1 into 100. Okay, that is, and that torque is clockwise or anti-clockwise? Clockwise torque. Okay, any other clockwise torque? No. Okay, then this should be balanced by what? Balanced by the anti-clockwise torque. Okay, what is the anti-clockwise torque? What is the anti-clockwise torque of mg? What is the weight? The weight is capital M into G. How much is that? 0.2 G. That is the weight into what distance? This distance. Correct? Yani ki into 50 centimeter. Plus what? Plus the torque of this. This is how much? 0.02 G, and this should be multiplied by, this is 70, so this distance would be how much? 30. And that's done. Is that clear? So this cancels out, this cancels out, this cancels out. So what are we left with? We're left with T1 is equal to 2510 plus this is 0.2, 0.6 divided by 10. Yani ki 10.6 divided by 10, yani ki 1.06 Newton. Clear? Any problem? Okay, so once you have calculated this, put this here and you can calculate T2. किस पॉइंट से? इस पॉइंट से लिया है, ठीक है, बट उसका कुछ खास फायदा into 20. Okay. Then T1 into 70. Huh, that is also correct. That is also correct. Is that clear? Any problem? Can I rub this off? Okay, write this down. Uniform ladder, length 10 meter, mass 16 kg. No, it's too much effort. I'll draw it. क्यों इन्वॉल्व किया तू आकृत को? अब हर चीज में तेरे को इन्वॉल्व करेगा तो तेरे को लोड हो जाएगा. चुप. Write down the question. Okay. Do you understand the situation? Do you understand my art? What? What? Very deep. Very elevated thought. वो तो आदमी जानेगा ना. Okay, so there is a ladder. There is a ladder. Mass 16 kg, length 10 meter. Okay, so the wall is smooth. The ground is rough. Angle is 37 degree. So इसमें लिखा है, I don't know, इसमें लिखा है there is an electrician of mass 60 kg at the center of the ladder. हाँ. Okay, at the center of the ladder. So what you need to calculate is, the normal force and frictional force by the ground. The normal force and frictional force by the ground. And minimum coefficient of friction. So that the electrician can work safely. Minimum coefficient of friction for electrician to work safely. तो जब इतना छोटा डायग्राम बनाता है तो साथ में मेरे को वो भी देना चाहिए, मैग्नीफाइंग ग्लास. 5 sin 37 डिग्री कैसे हुआ? ओके 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 ओके. Hmm, 10 cos 37 डिग्री होगा ना. दिस इज द लाइन, दिस इज द फोर्स. 10 cos 37 डिग्री. एग्जैक्टली सेम क्वेश्चन यार जो फर्स्ट वाला किए थे. एग्जैक्टली सेम क्वेश्चन. Okay, let's see. Okay, first of all, the free body diagram. So the ladder has mass 16 kg and this guy has mass 60 kg. So the combined mass is 70 kg. So 76. So what is the weight acting down? 76 g. ठीक है. Okay. इसमें भी there can be some intricacy. First of all, what is it? It is a ladder. Ladder कैसा होता है? Ladder has steps like these. Alright, ladder has steps like these. Okay, so if it is inclined and you're standing on a step, the force acting is, your weight acting is downwards, and the normal force acting would be upwards. The normal force acting would be upwards. Okay, so the force on the ladder is vertically down. If it is inclined, still you are standing on that one rod. Okay, correct, you are standing on that one rod. This is the step. So you are standing here. So your weight is acting down. So the normal force on this rod is acting down. Do you get this? Okay. If it were not a ladder, if it were a rod, if it were not a ladder, it was a rod. Okay, then what will happen? Then this guy would have been standing on what? On the surface. Is that correct? On the surface. And then normal force ka direction kya hota? The normal force का direction would have been perpendicular to that surface. क्यों नहीं खड़ा हो सकता? Friction can stop him. Don't you stand on an inclined surface? Don't you? Or can't you? You can stand on an inclined surface, right? So it can be done. That is detail. Okay, but the thing is, there would be difference. If it is a ladder, or it would have been a rod or a surface, then there would have been a difference in the direction of normal force. Is that clear? That's what I want to emphasize. Is that clear? Okay. Anyway, so but in this case this is a ladder, so this is 76 g. This would be normal force. The normal force here would be N2, and the friction acting here would be this. So if I talk about the equilibrium, N1 will be equal to F, and then N2 will be equal to how much? N2 will be equal to 76 g. Then I have to write the torque equation. About which point I should write the torque equation? I should write the torque equation about this point. That'll be convenient. It'll cancel off two forces. Okay, so let's write the torque equation. N1 ka torque, extend the line of action of force, drop a perpendicular. So I need what length? I need this length. And that length would be L cos 37 degree. So how much is L? L is 10. So this will be 10 cos 37 degree. So the clockwise torque due to N1 will be equal to N1 into 10 cos 37 degree. The anti-clockwise torque due to mg would be equal to extend the line of action of force, drop a perpendicular. So this is 8, this is 37 degree, so this is 8 sine 37 degree. Alright, so this becomes how much 76g into 8 sine 37 degree. Is that clear? Any problem writing the torque equation? Okay, yes, 5. Alright, so this comes out to be how much? So this is 76, 10 and g cancels. So this is 5 and then this is tan 37 degree. Tan 37 degree is 3 by 4. So this is 19. This is 285 Newton. Alright, so the frictional force is equal to how much? 285 Newton. And N2 तो already निकल चुका है. Okay, 760 Newton. Okay, so what is the value of minimum value of coefficient of friction? So friction should be less than equal to what? The maximum value of friction, and that is mu N2. Correct? So the friction would be less than equal to mu into N2. Friction किधर है? Where is friction? 285. 285 should be less than equal to N2. 760. So mu should be greater than equal to 285 upon 760. Okay, now whatever this comes out to be. Correct. Is that clear? Any problem? Chalo, next question. Can I rub this off? Okay, write down. The door of an almirah is 6 feet high, 1.5 feet wide, and weighs 8 kg. Door of an almirah is 6 feet high, 1.5 feet wide, and weighs 8 kg. The door is supported by two hinges. The door is supported by two hinges situated at a distance of 1 feet from the ends. The door is supported by two hinges situated at a distance of 1 feet from the ends. If the magnitude of forces exerted by the hinges, if the magnitude of the forces exerted by the hinges on the door are equal, if the magnitudes of the forces exerted by the hinges on the door are equal, find their magnitude. Almirah, 6 feet high, 1.5 feet wide, and the weight is what? The mass is 8 kg. The mass is 8 kg, and there are hinges 1 feet from the ends. Okay, and it is given that the hinges apply equal forces in magnitude. Alright, equal forces in magnitude. Then what do we have to find out? The force, the hinge force. Okay, so we need to find out the hinge force. Now listen up. Hinge force is बहुत बदतमीज किस्म का फोर्स है. Again, it is more what do you call it? It is more difficult to handle than even the compared to static friction. Okay, static friction के बारे में what do we know? We know there is a maximum value. Okay, it cannot exceed a maximum value, and the force is opposite to the tendency of relative motion. Okay, hinge force के बारे में we cannot say anything. Nothing. We cannot say anything about the hinge force. किधर लगेगा, कैसा लगेगा, we don't know. Okay, but there is a way to find out, and the way to find out is your force equations and torque equations. Everything will depend on that. Hinge force could be in any direction. It could have any magnitude, it could have any direction. There is no relative sense, so you can find out the direction of that force. Alright, sir. And we'll deal with hinge forces in detail later on, but I want to introduce hinge forces. Hinge forces are a bit tricky to solve. Okay. So I don't know, even when I'm drawing the free body diagram, I don't know in which direction is the hinge force going to act. Right, so what do we do? Okay, so what we can assume is, we can assume whatever is the direction of hinge force, we can resolve it in two components. Okay, so what we are saying is, let's say, let's call it fx, let's call it fy. Now the thing here is, I'm not sure fx will be in this direction, and I'm not sure fy will be in this direction. It could be opposite also. I don't know. Okay. What? Yes, negative. That is what we are banking on. Okay. Similarly for this one, I don't know. So I'll assume anything. Okay. So the magnitude of force is the same. Okay, the magnitude of the force is same. So it's not given that the components are also same. Okay. So if the magnitudes are same, at best what we can say is fx ka square plus fy square will be equal to fx prime square plus fy prime square. Okay. First of all, we'll look at the problem at length, then we'll look at how we can simplify that problem. Okay. I want you to be able to understand ki hinge mein what are the different factors we have to think about. Okay. First of all, this is clear. I'm not sure fx किधर होगा, fy किधर होगा. I'm not sure fx. ले सकते हैं नीचे, एकदम नीचे भी ले सकते हैं. So we don't know. We have just chosen a value. Okay. Is that clear? So the magnitude of forces is equal does not mean the components will also be equal. So all I can say is fx square plus fy square is equal to fx prime square plus fy prime square. Is that clear? Okay. Next, what are the other force? The other force is 8g, the weight of the door. Okay. Now let's think. This door is in rotational equilibrium as well as in translational equilibrium. Okay. This force is this door is in rotational equilibrium plus translational equilibrium. Okay. Now we need to think what are the vertical forces and what are the horizontal forces, and then we can find out a little about the nature of fx and fy. Okay. First of all, let's talk about the horizontal equilibrium. First, let's talk about the horizontal equilibrium. Okay. Now tell me, what are the forces in the horizontal direction? Fx and fx prime. I have drawn both the forces in the same direction. Is that correct or is that wrong? It has to be wrong. Why? Because if the forces are in the same direction, how would they cancel each other out? There are only two forces in the horizontal direction, fx and fx prime. Correct? If the net force is 0 in the horizontal direction, they have to be in opposite directions. Is that correct? Okay. Now can we think what will be the direction of fx or what will be the direction of fx prime? Which one is correct? If नहीं बोल रहे हैं, are you sure fx would be towards the right? Are you sure? Yes, no. Yes, no. You probably can be sure. You probably can be sure. I'll tell you why. Now let's think about torque. Let's also think about torque. Okay. So torque equation I can write about any point, but I choose to write the torque equation about this point for obvious reason. Why? Because fx prime and fy prime ka torque will cancel out. Okay. Now I'm writing the torque about this point. Is that correct? Okay. What is the torque of the weight? What is the torque of the weight? Yeah, direction. The direction, yes. The clockwise. The torque of weight is clockwise. Okay. That torque will be balanced by this hinge force. Okay, that torque would be balanced by the torque of this hinge force. Okay, tell me what will be the torque due to Fy. Think and tell me. The torque of Fy, this is the axis I'm choosing. This is the point about which I'm calculating torque. 0, excellent. Fy, 0, correct? Now which torque can balance it? The torque of Fx. So the torque of Fx has to be opposite to the torque of the weight. What is the torque of the weight? Clockwise. So what has to be the torque of Fx? Anti-clockwise. So what should be the direction? Excellent. Is that correct? Any problem? Do you get this? So what are the things we have locked down upon? Now that we have certain about the direction of Fx, we are also certain about the direction of Fx prime. Yes, no? Is that correct? Any problem? Clear? Huh. Clockwise direction. Kaise? This is the point and Fx is left. So anti-clockwise, no? Fy is equal to what? Fy ka torque will be 0. The force is passing through the point, right? So Fy ka torque is 0. Is that clear? Huh. Huh. If we take this point, then torque of Fx will be 0. Huh. 8g is clockwise, and then Fx prime ka torque is done, right? Okay, so we have locked down upon the direction of Fx and Fx prime. Okay, so what I'm telling you is not necessary to solve. In order to solve this problem, we have to think so much. Okay, we can solve it easily. We can do that, but I want you to think about everything that you can think about in the hinge problems. Okay, is that clear? Okay, now let's talk about Fy and Fy prime. Okay, so what we can do is we can talk about the vertical equilibrium. So 8g is down, so one of the forces has to be up. Okay, I'm not sure ki either this would be up or down, or this would be up or down. I don't know. Okay, then again what I'll use is I can use torque. Okay, how can I use torque? Let's calculate the torque about the center. Okay, so 80g ka torque would be 0. 80g ka torque would be 0. Okay, now tell me what will be the torque of Fx? Anti-clockwise. What will be the torque of Fx prime? Fx ka torque would be anti-clockwise. Fx ka prime ka bhi torque would be, this is the point, will be anti-clockwise. Okay, so it has to be countered by what? It has to be countered by Fy and Fy prime. Okay, what we have already understood is that the magnitude of Fx and magnitude of Fx prime is same. Is that correct? The magnitude of Fx and Fx prime is same. So from here, can we say that the magnitude of Fy and Fy prime also has to be same, right? Okay, now think again. The torque about ATG, the torque of ATG is 0. Okay, the torque of Fx is anti-clockwise. Yes, the torque of Fx prime is anti-clock. Kisko dikkat ho rahi hai? This is the point. You're applying the force here. How would it rotate? Anti-clockwise. Point is here. You're applying the force over here. It will rotate anti-clockwise. Okay, so the anti-clockwise torque has to be balanced by the clockwise torque. Okay, तो clockwise torque किसका होगा? Fy and Fy prime दोनों का होना पड़ेगा. Because if Fy is in this direction and Fy prime is in the opposite direction, then what will happen? They'll cancel each other. Their torques will cancel each other. Fy का then clockwise हो जाएगा और Fy prime का anti-clockwise हो जाएगा. And they are equal in magnitude and they're also symmetric. So the torque will get cancelled. That means what? It has to be in the same direction. So Fy and Fy prime has to be in the same direction. And what direction that would be? Upwards. नहीं तो balance 8g को कैसे करेगा? Correct? So now we have arrived at the conclusion. What is that conclusion? Now Fx has to be left, Fx prime has to be right, Fy and Fy prime have to be up. Fx anti-clockwise, Fx prime anti-clockwise. So two anti-clockwise force torques that has to be balanced by clockwise torques, because if Fy is up and Fy prime is down, assume it, तो Fy का torque कैसा होगा और Fy prime का torque, won't they cancel each other? Then Fx and Fx prime का torque can never cancel each other, so it will never be able to remain in rotational equilibrium. Is that correct? Okay, so what we have done is we have found out everything. Actually in this problem we didn't have to do so much, we didn't have to think so much. Equation लिखते जो आना होता आ जाता, right? But it's good to understand how the hinge works, how you can find different things about the hinge. Okay, so without even solving the question, you are at least sure about the directions. Is that clear? Okay, now in order to solve the questions, what do we need? Vertical equilibrium, right? So 8g would be equal to what? Fy plus Fy prime. Are they same? They are same. So Fy will be equal to Fy prime, and that will be equal to how much? That will be equal to 4g, yani ki 40 Newton. Done. Next, what do we need to find out? We need to find out Fx. So to find out Fx, what should we use? Which equation? This? That'll cancel out. That'll become an identity. Torque equation, yes. Yes, we have to find out the torque equation. And about which point should I write the torque equation? I should either this or this. Both will do. Alright, so I'm writing the torque equation about this hinge. Okay, it is always, in most of the cases when we are dealing with hinge, it will be good if you write the torque equation about the hinge. Okay, because that way the forces of the hinge would not have any torque. Okay, so what is the torque of the weight? The torque of the weight would be 80g. Extend the line of action of force, drop a perpendicular. So I need this length. How much is that? 1.5 by 2. Alright, and that torque is clockwise. Now this torque will be balanced by which torque? This torque will be balanced by which torque? Fx ka torque. Fy will have no torque passing through the point. So Fx ka torque would be in what direction? Anti-clockwise, and how much would that be? Extend the line of action of force, drop a perpendicular. So what length is this? 4. So this should be equal to what? This should be equal to Fx into 4. So 15 Newton. And that will be the same as Fx prime. Cancel हो गया ना? Feet तो सारा cancel हो गया. Alright, okay, so you have Fx, you have Fy, you can find the magnitude. So the magnitude of force would be, the net hinge force would be equal to what? Fx square plus Fy square ka under root. Clear? Any problem? Okay, so more on hinge later on. Can I rub this off? Next up is something known as toppling. You know what is toppling? Huh? What is girna? There is a better word for toppling, better Hindi word for toppling. Ludhakna. Ludhakna. What is ludhakna? Roll. Right, so rolling is actually toppling. That we'll deal with later. Okay, but what do you understand by toppling? So something is here, or what do you have? Okay, this is here. So if I apply a force like this, it turns. Apply a force like this, it turns. This is known as toppling. Okay, and actually, how do we walk? How do we walk? पैर में पैर से चलते हैं, मत बोलना. हाँ? ओके, अच्छा, 1 साल का बच्चा होता है, उसको न्यूटन्स थर्ड लॉ तो नहीं पता होता है, वो कैसे चल लेता है? Alright, listen up. Okay, so the process of walking is also toppling. Okay, how do you walk? You are here on one foot, and then does your foot slide? It does not. Then you topple, you're on the next foot. Then you topple, you're on the next foot. Right? So this process of walking is also toppling. Okay, so what is important in toppling? That the point of contact, listen up. The important about toppling, that it topples about this point. Matlab, this point of contact does not slide. Alright. So if you are applying a force like this is going to sort of rotate like this and then tip over. Is that correct? Okay. But this, for toppling, this point of contact should not move. Is that clear? Okay. So we are going to understand how we can make something topple, or what will be the condition for toppling. Okay. So suppose this is a surface, this is a rough surface. Okay, so obviously if this does not have to move, there has to be sufficient friction. Correct? There has to be sufficient friction. Okay, let's say the mass is m and we are applying a force over here. Where? Okay, chalo. Let's apply a force over here. Okay, let's say the side is, this side is let's say A. Let's say this side is A. इसको B कर देते हैं, इसको A कर देते हैं. हाँ, you are absolutely right. Let's see the process. Okay. So what are the forces acting? Mg would be acting like this. The normal would be acting like this. Okay. What the friction would be acting? Like this. Okay, so for topple, the friction has to be sufficient. For toppling, the friction has to be sufficient that this surface does not slide. Is that correct? Okay, so what is the condition on F? F has to be less than equal to mu mg. Is that correct? Okay, so for toppling, what should we have? F should be less than equal to mu mg. Okay, I'm talking about pure toppling. Okay, like you have pure rotation, there is pure toppling. Pure toppling means this point does not move. It may happen that it slides also and it topples also, but that we'll deal with later. Okay, I'm talking about pure toppling. रोहित शेट्टी का मूवी में जैसे वो कुछ भी होता है. वैसे I gave you your homework. Nobody did that. ठीक है, okay, no problem. When I finish rotation, that will be your homework. Summer assignment. You did? ठीक है, we'll talk about that. So I asked you to take up any Rohit Shetty movie and find out all the things which are wrong physically. Alright. So the force should be less than equal to mu mg. Why? Because we don't want it to slide. Okay. Next, if it is toppling, or if it has a tendency to rotate, it means the torque on it is greater than 0. Then only it can rotate. Correct. Okay. So let's find out the torque. What is the torque? And torque we can find out about any point. Okay. So what point you want to choose? You want to choose the center. Okay, let's choose the center. So what is the torque of normal force? What is the torque of weight? What is the torque of F? The torque of F is 0. Yes, center से pass कर रहा है. Okay. नहीं, capital F. Yes, capital F. ठीक है, नाम बदल देते हैं, इसका P कर देते हैं. हम्म अब 26 ही लेटर हम क्या करें, कुछ तो ओवरलैप होगा ही. Okay, so n and mg का torque becomes what? Zero. Capital F का torque also becomes zero. Then friction का torque is non-zero. Friction का torque कैसे zero? Friction, momentum, F into F into F into F into a by 2. Yes, the friction का torque is there. Okay, now tell me, if I push something at the center, does it topple? ठीक है, does it topple? But from this, what are you seeing? What are you seeing? It is, what do you see? From here, what do you see? It is toppling. Right, so what's wrong over here? What is wrong in our assumptions? We chose center. नहीं, कहीं से भी कर लो. Your wish. चलो यहाँ से कर लो. करके देखो. F का torque becomes zero. Small f का torque becomes zero. Then n का torque would be how much? Clockwise. And mg का torque would be anti-clockwise. Won't they be same in magnitude? The torque would be same in magnitude. They cancel. बचा किसका torque? P का torque बच गया. Then again will have a tendency to topple. But do you think it will topple? It will not. So what is wrong in our assumption? What is wrong in our assumption? No. उसमें क्या गलती हो सकती है? I'm saying it is applied there. It is applied there. One more normal force. वो किधर से आएगा? एक के साथ एक free. हाँ. So that will be on the person who is applying the force, ना? P less than friction. नहीं, इसमें भी कोई assumption, कोई गलती नहीं. It can happen. It can happen. Okay. The thing is, and you don't know about this, but in certain situations, the body, to resist toppling, what it does is the normal force shifts. The normal force shifts. The normal force in this case will not pass through the center. The normal force will shift. ठीक है? Don't believe me? Try this. What do you want to try? नहीं, इस side shift करेगा. I'll tell you why. I'll tell you why. नहीं, इसी side shift करेगा. I'll tell you. I'll explain that. Don't worry. Okay. First of all, understand or feel कि ये shift करेगा. Normal force will shift. Okay. So you're like this. Okay. You're standing like this. Okay. So maybe stand on one foot. Okay. Do you feel equal pressure on all the points on your foot? Why not? I'm standing straight. Do you feel equal pressure on all points of your foot? You want to try it? चल आकृत खड़ा हो जा. Let's do it. One for science. Huh? Almost. Okay. Or I'll give you a situation. Now what I want you to do is, and I don't want to fall. Okay. I want you to tilt forward. I want you to tilt forward. Now tell me what happens. What do you feel? What do you feel? The pressure you'll feel the pressure same all throughout, or where you'll feel pressure somewhere more? When you're toppling, like when you're tilting like this, what do you feel? On the toe there is more pressure. Do you feel that? ठीक है? Yes or no? Or I'll make everyone do that. हाँ? चल खड़ा होके कर. Let's do it. चल. नहीं सबको नहीं, तेरे को बोला. ठीक है, आखिरी तो गिर जाएगा. नहीं, तेरा weight कम है. All right, so you can do that. Okay, you can when the class is over, you can try that on your own. Okay, or you can have a feel. Okay, when I'm tilting forward, there is more pressure on my toes. Okay, why is there more pressure on my toes? Because the normal force has shifted. Okay, and the normal force will shift in a way as to counter the torque which is trying to topple it. Do you get it? Okay, the normal force will shift in the direction or in the certain sense that it is going to counter the force which is trying to topple it, right? Okay, so what did we talk about? We talked about this point. Okay, so which force is trying to topple it? फ्रिक्शन. P का तो टॉर्क ही नहीं है. P का टॉर्क नहीं है, mg का टॉर्क नहीं है, n का टॉर्क अब होगा. Okay, P का टॉर्क नहीं है, mg का टॉर्क नहीं है. We're talking about the torque about the center. Okay, so there is no torque about for mg, there is no torque for P, but there is torque for friction. Okay, now this friction is trying to rotate it in what direction? Clockwise. So the normal force has to shift in a way that it provides the anti-clockwise torque so that it counters that clockwise torque. Okay, so where should it shift? It should shift towards the right. Is that clear? Any problem? Alright, so a better way would be, always a better way would be to think about the torque from this point. To think about torque from this point. Okay, because this is the point about which it is going to topple. उससे क्या होगा? The torque of friction will become 0. The torque of friction will become 0. Okay. Let's see. Wait. Okay, so basically what do we see? Look here. Okay, what do we see? We apply force at the center. Is it toppling? It's not. Take it. We apply a force a little higher. It topples. Take it. We apply a force at the highest point. It'll be easier to topple. Okay, so what are you seeing? The higher we apply the force, there will be more tendency of toppling. And that we can see if we analyze it like this. Alright? Okay. Now we are talking about the torque from this point. Okay. So if we are talking about the torque from this point, the torque of friction will become 0. Now realize that mg will have a constant torque. How much? Mg multiplied by this distance, that is b by 2. Mg will have a constant torque. Okay. Now what will be the torque of force F? About this point. What will be the torque of force F? F into h. Okay. If I increase the height, the torque of the force will become more. Okay, so if I increase the height, the torque becomes greater. So this will have a greater tendency to topple. Is that correct? Okay. So if it is at this height, let's say the normal force is over here and it balances it. Okay. Now it move it further. So what will happen to the normal force? It will move further. If I move it further up, it will going to move further towards the right. Okay, maximum how much can the normal shift? Till it reaches the end. Okay, obviously iske baad kya hoga? The normal force cannot be outside the body. Okay, it's a contact force. So jahan contact nahi hai, wahan it cannot exist, right? So the maximum the normal force can shift is till this point. Okay, so I want to find out what? I want to find out h max. कि maximum कितना height पे I apply the force so that it does not topple. Alright, h max means maximum how much, at what height I should apply the force that it does not topple. Okay, so the limiting condition, at the limiting condition, what is going to happen is the normal force would be at the edge. It will reach the edge. Is that clear? And now what we can do is we can find out the condition. Okay, and we are trying to find out the torque about which point? About this point. Is that clear? So at the limiting condition, what will be okay, so what is the condition of toppling? The condition of toppling is that this torque of F is greater than the torque of mg. Why? Because torque of friction is what? 0. Torque of normal is what? 0. Okay, so if the torque of F, capital F, becomes greater than the torque of mg, what will happen to the body? It is going to topple. Is that correct? Any problem? Okay, so what can I write? F into H, will that be the torque? F into H will be the torque of capital F, and that is clockwise. That will be countered by mg ka torque. The mg ka torque is anti-clockwise, and how much is that? Mg into how much? Extend the line of action of force, drop a perpendicular. So mg into b by 2. Correct? Is that clear? ठीक है, आई एम नॉट आस्किंग यू टू मेमोराइज दिस इज नो रिजल्ट, दिस इज नो फॉर्मूला, कोई फॉर्मूला नहीं है ये, ठीक है. इट्स अ सिंपल कंडीशन विच आई वांट यू टू अंडरस्टैंड, ठीक है. So what is the maximum height at which I can apply a force? This is the maximum height at which I can apply a force and the body will not topple. Correct? And secondly, for pure toppling, F should be less than equal to what? F should be less than equal to mu mg, so that it does not slide. Is that clear to everyone? Any problem? Clear? यही तो दिखाया है, this is it, this is the example, ठीक है. So this surface, this point, the point of contact should not slide. Yes, absolutely. अब उल्टा कर लो, if you fix h, ठीक है, what will happen? F max would be equal to what? mg upon b upon 2h, ठीक है. हाँ, max होगा ना, max. This is maximum force you can apply so that it does not topple. That is meant by max. Or you can say the minimum force you need to apply to make it topple. Same thing. हाँ, सेंटर पे अगर हम लोग बहुत फोर्स लगाएं, yes, topple होगा. Now you tell me. Now you are capable of answering that question. You are capable of answering that question. हाँ? That is a separate thing. Slide करेगा कि नहीं करेगा, that will depend on mu. Right? Slide करेगा कि नहीं करेगा, that will be a separate question. That will depend on mu. That has nothing to do with the dimensions or the height at which the force is being applied. Okay. Now you tell me, if I apply a force at the center and it is given that friction is sufficient so that it does not slide, it's sufficient. Now tell me, if I apply a force at the center, can it topple? Yes, no. If I apply a force at the center, can it topple? Yes, no. Why not? नहीं, that is if we fix h. देखो this condition, तो condition तो किसी एक पे होगा ना. This is maximum height for a constant force, for a particular force. This is maximum force for a particular height. You get this? Okay, so what are we talking about? We have fixed the height. We are talking about, we are pushing it at the center. So we have fixed the height. What is that height? A by 2. तो h की जगह लिख दो ना a by 2. So if the force is mg b by a, why won't it topple? If the force is greater than mg b by a, why won't it topple? It will topple. Is that clear? Okay, so the only condition for toppling is that the friction is sufficient that it does not slide, and then what should happen? That the torque, the net torque on the object should be greater than 0. Okay, the net torque should be greater than 0. If it is greater than 0, it is going to topple. Is that clear? Okay. Now you understand the condition for toppling, right? Did you understand it? What will be the condition for toppling? What will be the limiting condition? That the normal force reaches where? At the edge. Is that clear? Any problem? Can I rub this off? Now can you solve that question which we talked about? And I ask you, I'll deal with that later. ठीक है? Do you have that question? What was the question? Cubical block has edge A, rough inclined surface, okay, with inclination theta, with uniform speed. Okay, so it slides down with uniform speed. You had to find out what? The torque of normal force. Act about its center. अब सोचो, अब सोचो, अब सोचो. Right, now think. Hmm. Uniform speed, yes. It will be static friction. Slide कर रहा है तो static friction कैसे होगा दोस्त? The net force would be zero, yes. But how would that be static friction? हाँ, it should not be static friction, yes. तो तू क्या बोल रहा है? It should not be. Obviously, if it is sliding, it will be kinetic friction. Then it will. So that is given to you. It is not toppling. तो फिर निकालना क्या है? Read what निकालना क्या है? The torque of the normal force about the center. You have to calculate the torque of the normal force about the center. Yes, it is not toppling. It is given in the question. It is sliding. How do you know? Are you sure? पहले बना तो. Draw the free body diagram. Look at the torques. हाँ? नहीं, ये कहाँ दिया हुआ है? Calculate. Listen up. Oh, listen up. Calculate. If you have written it wrongly, correct it. Calculate the torque of normal force about the center. Find the torque of the normal force about the center. That's it. Zero. Yes. Excellent. Absolutely. And how much would be the torque of friction? सोच के बोल. Torque. mg sin theta into a by 2. Correct. Now find out at what distance from the center is the normal force acting. देखो, first of all, mg sin theta, mg cos theta, friction, normal. I don't know where is normal going to act. I don't know where is normal going to act. Okay, so mg sin theta and friction would be balanced. Why? Because it is moving with a constant speed. So the force along the inclined plane would be equal. So how much is the friction? The friction is equal to mg into sin theta. Is that correct? Any problem? Okay, now think about the torque. Choose any point. Which point you want to choose? Okay, choose the center. What is the torque of mg sin theta? What is the torque of mg cos theta? What is the torque of friction? mg sine theta into a by 2 anti-clockwise. Yes, anti-clockwise. So is it toppling? So who is balancing that torque? The normal force. So can the normal force pass through the center? It cannot pass through the center. So the normal force will shift. It will have to shift. Correct? So the normal force is going to shift, and I don't know by what amount, but the normal force is going to shift. But the question is, find the torque of the normal force. So the torque of normal force is balancing the torque of friction. So the torque of normal force will be equal to the torque of friction. And what is the torque of the friction? The torque of friction is mg sine theta, and this distance, this perpendicular distance, how much is that? A by 2. So the torque of normal force is also this. Is that clear? Any problem? Okay. Now can we calculate what is the distance at which the normal force is going to act? So what is the torque of friction? The torque of friction is mg sine theta into a by 2, and that torque is being balanced by the torque of normal force. So let's say this distance over here is x. So the torque of normal force would be equal to what? N into x. N would also be equal to mg cos theta, correct? So that will be n into x, yani ki mg cos theta into x. So this will be mg cos theta into x. To mg gaya, and then what do you have? X is equal to a by 2 tan theta. Is that clear? Normal force कितना होगा हीरो? All right, any problem? Clear? Right, so you have to think in those terms. If it is not toppling, then the normal force has to shift, or at least you have to find out what is the torque which is trying to move it, or which is trying to topple it. ब्रेक नहीं, अब खत्म हो जाएगा. 10 minutes the class will be over. Okay, so there is a mass on a rough inclined plane, and it has coefficient of friction mu. Okay, this is the base, this is the height. A cubical object, that is the base, that is the height. Okay, now what you're doing is, so you are gradually increasing theta. You are gradually increasing theta. The question is, will it topple first? Will it slide first? Or at least what will be the condition? Okay, so the question is, will it topple first or will it slide first? Mu कैसे change होएगा? Will it slide first? Will it topple first? हाँ, cubical है. हाँ. So what? ओ cubical बोला, अरे cuboidal है, चल. It's cuboidal. Will it slide first? Will it topple first? Right. निकाल लेना, कंडीशन याद नहीं है तो निकाल लेना. It is, the angle is gradually increased. That, so starting में तो that will be stationary. The angle is gradually increased. So the question is, will it topple first or will it slide first? Pakka. That depends upon height and slide किया. अच्छा. Uh, anyone has an eraser? Eraser. Eraser. हाँ. Try. हाँ. Try. हाँ. Correct. That is a good example. That bottle. Take it. Do that. That is a good example. Use this duster. First topple. No, use this duster. Okay, use this. Use this. First पहले उसको लंबा रख. हाँ, पहले उसको लंबा रख. See what happens. It slides. Coefficient of friction का थोड़ा. Uh, hmm. All right. ठीक है. Enough of experiments. So what are the different things? ठीक है. Experiments are good. What did you understand? Shabash. Shabash. Bottle will topple. Bottle will. Dimensions पे डिपेंड करेगा. वेरी गुड. Dimensions पे डिपेंड करेगा. और किस चीज पे डिपेंड करेगा? और friction पे डिपेंड करेगा. Okay, so in that eraser that you were trying to move, okay, what happened? It toppled. Why? And this book did not topple. Why? Coefficient of friction. Okay, because that has a larger coefficient of friction. So if the coefficient of friction is larger, it will have a greater tendency to topple. Okay. Next, it will also depend upon the dimension. Okay, so if you use that bottle, what did it happen? It toppled. Okay, if you use that bottle, it toppled. Okay, now, yeah, keep it like that. Let's see what happens. Keep it like that, yeah. It slides first. Alright, so what does it depend upon? The dimensions also. Alright, the dimensions also. Now let's calculate it mathematically. Okay? mg sin theta, mg cos theta. Okay, and I'm trying to find out what? The limiting condition that it topples. Okay, the limiting condition that it topples. तो normal किधर shift हो जाएगा? The normal will shift to the extreme. You're right. You're right. Okay, first of all, what is the condition for sliding? The condition for sliding is tan theta greater than equal to mu. That is the condition for sliding. उसमें कोई problem है? Okay, so if tan theta becomes greater than equal to mu, it will slide. Okay, now let's find out the condition for toppling. Okay, so for toppling, from where should I calculate the torque? I should calculate the torque about this point. नहीं, उल्टा कर दिया ना. उल्टा 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 हो गया. The normal will shift this side. Okay, so the torque of normal and friction becomes what? 0. So torque of normal and friction becomes 0. So torque of mg cos theta should be balanced by torque of mg sin theta. So mg sin theta is trying to topple it, and mg cos theta is trying to counter that. Is that correct? Okay, so what is the torque of mg sin theta? Torque of mg sin theta would be mg sin theta multiplied by what distance? Multiplied by this distance, h by 2. Okay, for toppling this should be greater than equal to what? This should be greater than equal to mg cos theta ka torque, and mg cos theta ka torque would be mg cos theta multiplied by this distance. How much is that? B by 2. Cancels, 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 cancels. So that gives me tan theta should be greater than equal to B by H. Tan theta should be greater than equal to B by H. Okay, so if tan theta is greater than equal to B by H, matlab the ratio of the base and the height, then it will topple. Okay, so what do you understand from here? So what do you understand here? Okay, so it will depend which is greater. Is mu greater or is B by H greater? Okay, so if mu is greater than B by H, means what? Theta is increasing, so tan theta is increasing. So tan theta will reach which value first? B by H first. Tan theta will reach B by H first. So what will happen? It will topple first. Okay, so this will be topple first. Is that correct? And if mu is less than B by H, increasing tan theta, which value will it reach first? It will reach mu first. In that case, what will happen? It will slide first. Is that clear? That is the condition. Okay? So if something has a larger base, its tendency to topple would be lesser or greater? Its tendency to topple would be lesser. Okay, so in that case you took a bottle and you put it like this. So what happened? The base was small. So in that case what happened? It toppled. But when you put it like this, in that case the base was larger. So what happened? It did not topple, it slid first. Is that clear? Any problem? Okay, and that is why. Okay, let's do one more question, last question. You'll understand what I want to tell. Last question. Kya? Mu less than B by H. So increasing tan theta will reach which value first? It will reach mu first or it will reach B by H first? Mu first. So if it reaches mu first, what is going to happen? It will slide. Is that clear? Can I rub this off? ठीक है, and ये सब कोई condition याद करने वाला नहीं है. Alright, this is nothing to remember. Situation change कर देगा. This will be of no use to you. Alright, the thing is understand the concept. So I'm showing you the top view. Okay, so there is a car going with a speed v in a circle of radius r. Okay. Now I'm showing you the side view. Matlab, the car has a width b and the car has a height h. Okay. Matlab, first of all, you understand that if the car is going like this in a circle, and this is what I'm trying to show you. Okay, the car has a width b and a height h. Is that clear? Okay, so the question is, the maximum speed, friction is sufficient so that it does not slide. It is given to you. Friction is sufficient to prevent sliding. It is given to you. Okay, now the question is, find the maximum speed with which it can take a safe turn. वो तो friction is sufficient. So friction is sufficient matlab it is not going to slide. ठीक है? Now the question is, what is the maximum speed with which it can turn to make a safe turn? ठीक है? मतलब what should not happen? It should not topple. Okay, it should not topple. So the condition is that it should not topple. कैसे किया? कैसे किया? मतलब मेरे को मालूम नहीं आंसर सही है कि नहीं, बट लॉजिक क्या है इसके पीछे? नो, गलत 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 आया है, गलत आया है. Okay, so how should you think about it? ठीक है, first of all, किस what frame do you want to solve it with? In which frame you want to solve it? If it topples, the torque has to be greater than 0. If it topples, the torque has to be greater than 0. Okay, so it would be a good idea to get into what? To get into the frame of the car. ठीक है? So what you should do is, ऐसे भी कर सकते हैं, you can solve it without getting into the frame of the car, but this will be better. If you are in the frame of the car is stationary. Okay, if you are in the frame of the car is stationary. What are the forces acting? The forces acting would be, which force? The centrifugal force, right? The centrifugal force. The centrifugal force is m omega square r, and this would be the same as mv square by r. Okay, and then friction would be acting. Friction would be acting like this. Then mg would be acting. How would normal act? Normal will not act normal, it will shift. Is that correct? And which direction will it shift? It will shift in this direction. Because when it topples, it will topple about which point? If it topples, it is going to topple about this point. That is correct. If it topples, it is going to topple about this point. Okay, so this torque is what? This torque is clockwise. This torque is clockwise, so it has to be countered by which torque? Huh? mv square by r का torque क्या होगा? It will be clockwise. ठीक है, so it has to be, so we can calculate it about any point. ठीक है, the thing is something like this would happen. Okay, but normal will shift to the maximum. Normal will shift to the maximum. ठीक है? Okay. हाँ. किस point के about? You can choose any point. Okay, you can choose any point. You can choose this point. You can choose this point. It will be the same. ठीक है? So if you want, we can choose about this point. नहीं, same ही आएगा, same ही आएगा. I'll tell you, you'll have to write two equations. Okay, first of all, choose any point you want. Which point you want? This मतलब क्या? This point. ठीक है, all right. Okay, so the torque of normal force and the torque of friction becomes 0. Okay, the torque of normal and the torque of friction becomes 0. So this torque, mv square by r का torque will be balanced by which torque? mg का torque. Is that correct? Okay, so for it to not topple, the torque of mv square by r will be how much? mv square multiplied by h by 2. Okay, and this should be less than equal to which torque? Is that correct? ठीक है, so v should be what? V should be less than equal to mg, yeah, this should be less than equal to bg by सही है, वही आ रहा था क्या? गुड, बट तुक्का कितना लगेगा मेरे को मालूम नहीं. आ रहा था तो अच्छी बात है, बट always I don't know if it be like that. Okay, anyway, so this should be, v should be less than equal to under root of gbr divided by h. Is that clear? Any problem? हाँ, एक ही इक्वेशन लिखना पड़ेगा. You are right. But इसके about भी we can calculate. इसके about mv square by r और mg का torque will be 0. Then normal का torque will be equal to friction का torque. So friction will be equal to mv square by r, and normal will be equal to mg. The same equation will come. Okay, so this is the maximum speed with which you can take the turn so that it does not topple. So what do you understand? The ratio of b to h should be large. In order to take a turn, in order to take a safe turn, what should in order to take a turn at a high speed, the ratio of b to h should be high, and that is what you see in Formula 1 cars, right? Because they have very large base compared to the height. Why? Because they want to turn at a large speed. Is that clear? Bikes maybe it turns. Bike maybe it bends. It has to bends. हाँ, knee का भी support लेता है, and it bends. If you want to take a turn at a very high speed, you have to bend it more. क्या बोला? क्या बोला? हाँ. कौन ड्रिफ्ट सिखाने वाला था? कपल जोक्स है. Okay, coupling. Okay. Okay. Anyway, so that's we'll meet in the next class. जा घर जा.